Hello everyone. So in this video today we will learn about how to predict the formation of a precipitate if we are given a Ksp value of any ionic compound. The ionic compound considered in this example is calcium fluoride, right? And the formula of calcium fluoride will be CaF2, right? And we are given the value of Ksp of this compound at 298 kelvins, and they have dissolved 1.0 times 10 to the minus 3 grams of calcium fluoride in 1 liter of water at 298 Kelvin, right? And we have to predict whether a precipitate will form or not. So first of all, before we start doing the solution, start writing the solution, let's discuss the plan, like what's the plan of attack to this problem, right? So in these kind of problems where you have to predict the formation of a precipitate given Ksp, we always find ionic product and compare that with Ksp, right? Compare ionic product, which we also denote with a Qsp, and compare Qsp with Ksp, right? If your Qsp comes out to be greater than Ksp, then you will say that a precipitate, which I write in short form as PPT, will form, right? But a precipitate will form. And if Qsp comes out to be less than Ksp, that would mean that a precipitate will not form, right? Will not form. And in case if your Qsp comes out to be equal to Ksp, and in that situation you can conclude that a saturated solution is formed, right? A saturated solution is formed, right? So first of all, in order to calculate the ionic product of dissolution of calcium fluoride in 1 liter of water, let us just write the dissolution of calcium fluoride in terms of a chemical equation, which is calcium fluoride, CaF2, in the solid state, and that establishes an equilibrium with its ions, which are calcium 2 positive in the aqueous form and fluoride ion in the aqueous form. And let's just balance this equation, because you have 2 fluorine atoms, so 2 fluoride ions will be formed for each calcium fluoride, and 1 calcium 2 positive ion will be formed, right? So the mole ratio of calcium fluoride to calcium 2 positive is 1:1, and from here to here it's 1:2, right? We will make use of this mole ratio. Okay, now if we let's just write the expression for the ionic product. So ionic product is equal to the concentration of products, which is calcium 2 positive, and raised to the power its stoichiometric coefficient, which is 1, and the concentration of fluoride ions, and raised to the power its stoichiometry, which is 2, right? This one. Now in this equation of ionic product, we need the concentrations of calcium 2 positive ion and the concentration of fluoride ions, right? But we only have the mass of calcium fluoride, right? So in order to find the concentration, we need the number of moles and the volume. The volume is given to be equal to 1 liter, right? Let's just find the number of moles from the given mass of calcium fluoride. So the number of moles of calcium fluoride would be equal to the given mass of calcium fluoride, which is 1.0 times 10 to the minus 3 gram, divided by its molar mass. And the molar mass of calcium fluoride is 78.07 grams per mole, and after solving, this comes out to be equal to 1.28090 times 10 to the minus 5 mole, right? Now if you look at the mole ratio here, from the mole ratio, the number of moles of calcium ions must be equal to the number of moles of calcium fluoride, right? The same thing, 1.28090 times 10 to the minus 5 mole, and number of moles of fluoride ions will be equal to double the number of moles of calcium fluoride, right, which comes up to equal to 2 times 1.28090 times 10 to the minus 5, which is equal to 2.5618 times 10 to the minus 5 moles, right? Okay, but we need the concentrations, but we have the number of moles. Since the volume is 1 liter, right, the calcium fluoride is dissolved in 1 liter of water, right? Therefore the concentration is pretty easy to find. Just so the concentration of calcium 2 positive would be the number of moles, which is 1.28090 times 10 to the minus 5 divided by 1 liter, right, which is the same number, 1.28090 times 10 to the minus 5. And similarly the concentration of fluoride ions would be equal to the same number, which is 2.5618 divided times 10 to the minus 5 divided by 1 liter, which is the same number again, 2.5. So this is 2.5618 times 10 to the minus 5, and this is moles per liter. This is also moles per liter. Okay, now let us just plug in these two numbers in this expression of ionic product, right? Therefore ionic product, or you can call it QSP, is equal to the concentration of calcium 2 positive, which is 1.28090 times 10 to the minus 5, right, this times 2.5618 times 10 to the minus 5 whole square. And if you solve this in your calculator, you will get 8.40631 times 10 to the minus 15, right? But if you look at the data given, the KSP value, the mass of the calcium fluoride given, this is given in two significant figures, right? Two significant figures. So we will also report the QSP in two significant figures, which is only 8.4 times 10 to the minus 15. This is QSP, right? Now what's the value of KSP? KSP is 3.2 times 10 to the minus 11. Now KSP equals to 3.2 times 10 to the minus 11. Now comparing QSP and KSP, what do you think? If you look at the order of magnitude, this number is quite smaller, right? QSP is smaller than KSP, right? Therefore no precipitate will form, right? No precipitate will form. Yep, so it was a pretty easy problem. In a nutshell, what you have to do is in these kind of problems is to find the ionic product, and in order to find the ionic product you would need this equation and the concentrations of the ions, right? And in this case you are given the mass of the calcium fluoride, right? But you can be given the data in some other format as well, and you will have to find the concentrations from that data, right? And after you find the concentration, just plug them in the ionic product formula and you will find the QSP, and then compare the QSP with KSP and find out whether QSP comes out to be less than KSP or greater than KSP or equal to KSP, right? So, and you can conclude your results accordingly. I hope that you guys have got the concepts through this problem, right? And if you guys have any questions, please write them in the comment section below, and I will get back to you as soon as possible with the solutions. Thank you very much. I will see you in the next video. Bye bye guys, take care.